First of all, toxic chemicals. Here are some things that I think are pretty certain about toxic chemicals. The first is that fracking uses toxic chemicals. I'll show you in a moment that I think there's little risk of those chemicals migrating through fractures to contaminate aquifers, no matter what you see in all the different media, and I'll explain why. The other thing is that other energy industries, unfortunately, also need to use toxic chemicals. So that's something that isn't really mentioned in a lot of the sources we've seen, but I'll show you that. And then I think with respect to toxic chemicals, the real issue is spills at the surface. So let's go through these. First of all, since Gasland was originally shown, oil companies have in fact disclosed their fracking chemicals to Congress in 2011. There's this nice report. You can download it off the web at this link. And it's not 600 and something chemicals. It's in fact 750 chemicals total. But that actually shouldn't scare you, because let's look at the list. Among those chemicals include silicon dioxide, that's sand, sodium chloride, table salt, essential oils. Ooh, this is beginning to sound like a nice exfoliating bath. Walnut shells, that's a chemical listed on this list of 750. Cellulose, that's another word for paper, or the materials that make paper up. And xanthan gum, if you ate something in a package today, is a good chance you ate some xanthan gum. So the fact that there are 750 of these shouldn't worry you. What should worry you is that this list includes 29 chemicals that are definitely toxic, including diesel, sulfuric acid, hydrofluoric acid, lead, and the material for antifreeze. So when you hear these numbers, you really don't care how many there are. You care about how many of them are toxic and how much of those toxic materials are actually used. And interesting, actually, of these 29, actually 24 of them are regulated as air pollutants by the EPA, not necessarily for their water hazards. So now, we've talked about bias in visual media. Or bias in media. Well, it is true in visual media as well. Here are two different videos I found on YouTube. You can see the links down here. One from a company that basically sells their services to trial lawyers, people that want to sue oil and gas companies to get money for fracking. So here's how they explain fracking with respect to the danger of water contamination. So here's a freshwater aquifer, and they show the water being sucked into a groundwater well for use by this home. And then here's that drill pad nearby, and here they show that you're trying to drill down to about 6,000 to 8,000 feet to get oil and gas out of the shale. So that's how they've drawn this. Now here's an oil and gas company's version of basically the same figure. They have the ground up here at the top, and here is a freshwater aquifer. It's shown in blue in the top one, shown in blue in this one. Let's watch how they show it. So there we are, and now we're going down, down, down. Oh my goodness, 6,000 feet, or actually, they say about 5,000 to 13,000 feet. What you see is this little symbol right here in the trial lawyers exhibit. There's a little symbol that says, we've cut a whole bunch of things out. We've compressed things down. So they basically cut out a huge chunk of earth. And that's not necessarily legitimate. It makes it look like the groundwater is happening, the drilling is happening much closer to the surface in all that action. So actually, when they later in that same video show contaminants leaking out from the horizontal section of the fracked well, they show this leak easily going into the aquifer, and you can visually see that green, nasty stuff going there. Whereas Marathon Oil shows these tiny little fractures, and that contamination, that green nasty stuff, they shows the same color conveniently, is totally contained. So we said that we need to triangulate between these sources. The truth actually lies somewhere in between these two things, and let's actually look at this to scale. First, actually, you can see a figure that's from the Gasland movie, their website. They exaggerated this even further here with these fractures going right up into the aquifer and contaminating the aquifer. And they've actually, if you look at their link today, this is a figure that's floating around on Google image search. They've actually changed their figure to make it a little bit more realistic, because this was totally misleading. The actual figure looks more like this. This is something like 6,000 feet of rock. These little things on the left side here are statues of Liberty. Statue of Liberty is about 300 feet tall, so 6,000 feet is 20 statues of Liberty worth. Here is the oil and gas rig at the top here at the surface. It drills down 6,000 feet. Now, most drinking water aquifers are just a thin layer somewhere in the top 1,000 feet or so of that, just a little tiny blip in there. And the longest fractures that break up the rock in hydrofracking are usually here at around 1,500 feet long. So basically all this material in here, these rocks have successfully kept the gas trapped for millions of years. They've been intact and they're not interrupted by these hydrofracking fractures. So when you have this much distance between the fracked layer and the aquifers, there is very little chance of contamination going from down deep up into the surface aquifers. Of course, if things were closer, this would be a different story, but all of the places that have been fracked so far to date have vast expanses of rock, thousands of feet, sometimes much longer than what you see here, in between the fractures and the aquifer. So fracking does use toxic chemicals, that's true. So let's look at a scientific journal article. I'll show you in a moment which one that is, but you can see it, you can click on this link here. So this article here talks about, in this industry, manufacturing and production processes require large amounts of water that result in an important discharged industrial effluents. Among discharged pollutants, the hydrofluoric acid is significantly used. Wastewaters are considered highly toxic and need to be strictly monitored and regulated. Sounds scary, doesn't it? You don't usually see that sort of scary language in a scientific journal, but what's interesting about this is that I fooled you a little bit. This article here is not about fracking. That's not the industry they're talking about. They are talking about solar cells, the things you put on your roofs. In fact, fracking and solar cell manufacturing actually use very similar toxic chemicals, and the wastewater from both of those processes needs to be disposed of somehow. So when you say toxic chemicals are used in fracking, that's true, but your alternative is a great thing like a solar cell, which also uses the same toxic chemicals, and quite a few of them as well. So should we outlaw solar cells then because they use toxic chemicals? The answer is probably not. I mean, the benefits of solar cells vastly outweigh these costs. But what that means is that when we say that fracking uses toxic chemicals, we also need to consider the costs and the benefits. Do the benefits of fracking outweigh the cost of using those toxic chemicals? And that's the question you need to be asking yourself. Some information about those costs that's kind of important. This is the data from the Earth Justice database of documented problems, and there were not nearly as many problems in that database as people had claimed in the Gasland movie. Just a few dozen of them, and one of the things you notice though is that spills do happen. The most common types of accidents are indeed spills, and there's not much you can do about them. I tried to make that simulator that we did, the Fracking natural gas extraction simulator, really drive that home, that you've got people who are doing this drilling, and people make mistakes. So you've got them all going out to all these different well sites in all sorts of different places. It's hard to control what happens there, and spills happen. So that's a very real risk, and a spill at the surface, that is much worse than something injecting these chemicals down deep, because a spill at the surface can easily get into surface water or percolate into the groundwater and cause major problems to drinking water. So spills are a real hazard when it comes to toxic chemicals in fracking.